Hey guys, we're going to talk about integer exponents because we're going to start getting into exponential functions. And on exercise 1, they want us to just fill in a table to give us an idea of what happens when you have an exponential function, which is, again, repeated multiplication. So what you'll see with a lot of these, 9 times 3, 27, and then with the positive ones, you're going to see that each one to get the next one is multiplied by 3. And then when you work towards the negative exponents, which we'll get into today, you will get decimals for each of those. And how you would find the exact value is by taking the calculator, and if you wanted to work backwards like I am on this one, you would want to take the number you got, 1, and divide it by 3 to work backwards to find the answer. So like in this case, it's 0.33 repeating, which is again 1/3. So what you'll see happen with these negative exponents is that they're not negative answers. They're actually fractions that are being multiplied again by that base factor, which in this case is the number 3. So you can kind of see the definitions underneath, which talks about positive exponents, the rule if you have an exponent of 0, and how a negative exponent would look. So the big thing is that if you have an exponent, let's say 2 to the third, which that would equal the number 8, 2 to the negative third is similar in that 8 is part of the answer, but again, it's a fraction. So negative exponents, again, are fractions. That's one of the big ideas that we need to get out of these notes. So I'm going to go ahead and erase these. We're going to look at some examples. Okay. Now, exercise 2, it says they give us an exponential function, and they want us to evaluate each of the following. It says without using a calculator, but if you want to, feel free to, because you get to use one on the regions. For this one here, we have 20 times 2 to the x. So I'm going to replace that x. I'm going to erase the x right now, and I'm going to put a 2 in its place. So 2 squared would be 4, and then 4 times 20 would be 80. That would be my numeric answer. For 0, again, it's just 20 times 2 to the 0 power. And to the 0 power is 1. So 20 times 1 would just be 20. And then for negative 2, we'd have 20. And then 2 in the parentheses to the negative 2 power. And again, this is going to be a fraction. So 2 to the negative 2 power is going to be 1 over 4. So it's 20 times 1/4, which would be 5. So if x increases by 3, that means our exponent. So if we went from 2 squared and we went to 2 to the 5th, they want to know what factor we're increasing by. So if I had something like this, 2 squared, that's 4. 2 to the 5th would be 2 times 2 times 2 times 2 times 2, which is 32. The factor you'd increase by in this case would be 32 divided by 4, which is 8. So if I took a number, or an exponent, and raised it by 3, and my base is 2, that means I'm multiplying by 3 more 2's, which would be the reason why I got that 8. So that number would be 8 times higher. Now we're going to spend some time doing review of some of the exponent rules we talked about in the first unit. So if you go to the back of this page, and again, with these questions, the idea is for a product, you are going to add the exponents. So we got 2 to the third times 2 to the fourth. This will be 2 to the 7th. And again, 2 to the third is 2 times 2 times 2, and 2 to the fourth is 4 more of them. So this is why we get that 2 to the 7th. If we're talking about exercise 4, I know I'm skipping ahead, 2 to the third times 2 to the negative first. Well, in this case, what we would have is 2 times 2 times 2, and then because 2 to the negative first is the fraction 1 over 2, that would mean we'd have a 2 on the bottom. And when you divide, you also can use that as kind of canceling out. So 2 to the third times 2 to the negative first is going to end up being 2 to the second, which in this case would be 4. So, but as an exponent, that's what it would have looked like. So for C, they're asking if this does support the extension of what we talked about with adding exponents when you're multiplying. And it does, because when we're doing a negative exponent brings in a fraction, which is division. And this works because division and multiplication are opposites. Now, if we look at a different property, another property that we've talked about before, if we're talking about, in this case, a power raised to another power, again, the outside exponent, this is going to be 3 to the 6th. And the reason it's going to be that is because you have 3 squared times 3 squared times 3 squared. So 2, 4, and 6 is the exponent. So that's why we have the rule from before. And then for exercise 6, which I'm going to erase this from the previous exercise, they're asking, consider this expression, 3 to the negative second power, and then raised to a power of 4. So we have 4 of these 3 to the negative seconds. So we'd have negative 2, negative 4, negative 6, negative 8. And again, if we write these as fractions, it's 1 over 3 to the second. So we got 4 of these. And if we wrote it out even farther, you'd have 8 3s in the bottom of this fraction. Okay, which would be 1 over 3 to the 8, which again would be 3 to the negative 8 as a negative exponent. So using our rules for exponents, if you have a power raised to a power, or if you have a power times the same base in another power, those rules still apply for negative exponents like they did for positive.